Amidst the pantheon of Greek gods, few are more revered than Artemis, goddess of the hunt, chastity, and the moon, mistress of animals, daughter of Zeus and twin sister of Apollo. Famed for her pledge to never marry, Artemis has stood as a feminist icon for millennia, though that time she turned a peeping Tom into a stag and set his own hunting dogs against him probably helped a little bit. It seems only fitting then that NASA has named after her a trailblazing mission that will see both the first woman and first person of color set foot on the moon. In fact, NASA has been naming its missions after Zeus's progeny since the advent of spaceflight. There was the Mercury program in 1958 using the Roman spelling of Hermes, then Gemini in 68, followed by Apollo in 73. NASA took a quick break from the naming convention during the shuttle era, but revived it when it formally established the Artemis program in 2017. Working with the ESA, CSA, JAXA, and a slew of private corporations, NASA's goal for Artemis is simple: to reestablish a human foothold on the moon for the first time since 1972 and stay there. Just as Artemis the goddess grew out of earlier pre-Hellenistic mythology, Artemis the moon mission was born from the ashes of the earlier Constellation program from the early 2000s, which sought to land on the moon by 2020. Specifically, Artemis is reusing the Ares 1, Ares 5, and Orion crew exploration vehicle that were developed as part of that effort. In 2010, then-President Barack Obama announced that the non-Orion bits of Constellation were being canceled, while simultaneously calling for $6 billion in additional funding, with a goal of putting humans on Mars by the mid-2030s. This became the NASA Authorization Act of 2010 and formally kicked off development of the SLS Space Launch System, the most powerful rocket NASA has built to date. The Artemis program was helped further in December of 2017 when former President Donald Trump signed Space Policy Directive 1, SPD-1. That policy change provides a US-led integrated program with private sector partners for a human return to the moon, followed by missions to Mars and beyond, and authorized the campaign that would become the Artemis mission 2 years later. In 2019, then Vice President Mike Pence announced that the program's goals were accelerating. The moon landing would be pushed up 4 years to 2024, though the original goal of Mars in the 2030s remained unchanged. We know NASA can put people on the moon. It's the whole keeping them there alive that's the issue. The moon, for all of its tide-inducing benefits here on Earth, is very inhospitable to life, what with its general lack of breathable atmosphere and liquid water, weak gravity, massive temperature swings, and razor-sharp, statically charged dust. The first colonists will need power, heat, atmosphere, and potable water, all of which will have to either be brought from Earth or extracted locally from the surrounding regolith. Complicating matters, the moon, at 230,000 miles away, is about 1,000 times further than the International Space Station, and getting a crew with everything they need to survive for more than a few days is going to require multiple trips, not just from Earth to the moon, but also from lunar orbit down to the surface and back. But high risk, high reward logistical nightmares are kind of NASA's whole deal. As such, the Artemis program is split between SLS missions, which will eventually bring the human crew to the moon, and the support missions, which will bring, well, basically everything else. That includes robotic rovers, the human landing system, as well as moon base and gateway components, along with all the logistical support and infrastructure stuff that they'll require. The SLS missions are built around NASA's new Deep Space Exploration System, which comprises the SLS Super Heavy Lift Launch Vehicle, the Orion spacecraft, and the Exploration Ground Systems at Kennedy Space Center. The SLS is the single most powerful rocket humanity has ever built, and given its modular, evolvable design, will likely continue to be for the foreseeable future. Its initial configuration, dubbed Block 1, consists of just the core stage with 4 RS-25 engines that used to fly aboard the space shuttle and 2 5-segment solid rocket boosters. Once the SLS breaks atmosphere, its interim cryogenic propulsion stage takes over for in-space navigation. Altogether, the core stage will produce 8.8 million pounds of thrust and be capable of pushing 27 metric tons of cargo out to the moon at speeds in excess of 24,500 miles per hour. The Artemis 1 mission that launched back in November, as well as the next 2 Artemis missions, are and will be powered by Block 1 rockets. Block 1B will include an additional exploration upper stage built by Boeing and composed of 4 RL-10C3 engines that produce almost 4 times as much thrust as the ICPS. That additional engine will enable the space agency to haul 38 tons of cargo out of Earth's gravity well. The SLS's final form for now will be Block 2, standing at more than 30 stories tall, weighing the equivalent of 10 fully loaded 747s. The Block 2s will produce 9.2 million pounds of thrust and push 46 million tons of stuff into deep space. Once that configuration comes online, NASA expects it to take on much of the heavy lifting in delivering crews and cargo to the moon. Riding atop the SLS's multi-ton controlled explosions is the Orion spacecraft, the first crew capsule in more than a generation designed for space exploration. Designed and built with help from the ESA, the Orion sandwiches a 4-person crew cabin in between a services module that holds all the important life support, navigation, and propulsion systems, and a launch abort system that will forcibly eject the crew capsule from the larger launch vehicle if a catastrophic failure occurs during liftoff. The 50-foot-tall LAS weighs 16,000 pounds and is designed to engage within milliseconds of a launch going sideways, lifting the crew cabin away from the rest of the SLS at Mach 1.2. The Orion main cabin is just under 16 feet tall and just over 16 feet in diameter. Its 4-wing solar array produces 11 kilowatts of power, and the attached service module holds enough air and water to keep the crew alive, if a bit panicked and stir-crazy, for up to 3 weeks. Located at the Kennedy Space Center in Florida, the Artemis program's exploration ground systems includes the Vehicle Assembly Building, the Launch Control Center, the firing rooms, mobile launchers, and the crawlers that haul rockets out to the launch pads. Oh, and also the launch pads themselves, specifically famed Launch Pad 39B. NASA already has 5 main Artemis launches scheduled. The uncrewed Artemis 1, again, successfully launched in November. Artemis 2, which will carry 4 live astronauts for the first time but only loop around the moon, that launches in 2024. Artemis 3 will go up in 2025, and it's expected to be the first to actually set down on the moon. Artemis 4 is slated for 2027, and that's going to deliver half of the lunar gateway as well as debut the EUS, while Artemis 5 is set to deliver the other half of the gateway in 2028. From there, NASA has some thoughts on Artemis missions 6 through 10, which will run 2029 through 2033, but has not finalized any details on those as of yet. Before we can even start thinking about our chances of survival on Mars, we need to build confidence in our ability to survive on the moon. The Artemis support missions will do just that. The Capstone mission in June, for example, successfully launched a 55-pound CubeSat to confirm NASA's math for the much larger Gateway's future orbital path. While in orbit, the Capstone will communicate and coordinate some of its maneuvers with the Lunar Reconnaissance Orbiter, which has been circling the moon since 2009. In 2023, NASA also plans to launch the Viper robotic rover to the moon's south pole, where it will search the lowest, darkest, coldest craters for accessible water ice. Finding a source for H2O is of paramount importance to the long-term viability of the colony. In space, water isn't just for drinking and bathing. It can be split into its component atoms and used to fuel our oxidizing rockets, potentially turning the moon into an orbital gas station as we push further out from Earth. The rover and other colony-assisting robots will be delivered to the surface as part of NASA's Commercial Lunar Payload Services program, the CLPS. Similarly, any habitat established on the surface will need an ample supply of electricity to remain online. Solar charging is one obvious choice, but NASA has never been one to underprepare and has already selected 3 aerospace companies to develop nuclear power sources for potential deployment. In addition to a surface installation, NASA plans on putting a full-fledged space station, dubbed the Lunar Gateway, into orbit around the moon, where it will serve much the same purpose as the ISS does today. Visiting researchers will stay aboard the Pressurized Habitation and Logistics Outpost module, or HALO, where they'll have access to research facilities, remote rover controls, and docking for both Orion capsules from Earth and HLS landers to the moon's surface. A 60-kilowatt solar plant will provide power to the station, which also serves as a communications relay hub back to the planet. The Gateway will very much be an international operation. As NASA points out, Canada's CSA is providing advanced robotics for use upon the station, the ESA is supplying a second living module called the International Habitat, or IHAB, as well as the eSpirit Communications module, and an array of research CubeSats. Japan's JAXA will kick in additional habitat components and assist with resupply logistics. From the Gateway, astronauts and researchers will ferry down to the moon's surface to collect samples, run experiments, and conduct observations. They'll be shuttled aboard the Human Landing System, a reusable lunar lander program currently being operated out of the Marshall Space Flight Center in Huntsville, Alabama. NASA selected SpaceX's Starship as its initial HLS in April 2021, awarding the company $2.9 billion to further advance the vehicle's development. The agency then awarded SpaceX another $1.15 billion this past November as part of the Option B contract modification. This extra money will help fund planned upgrades to the spacecraft, which is being modified from the base Starship design for use on and around the moon's surface. Researchers, however, will not be content to travel nearly 250,000 miles just to set down on the moon and look out the lander's windows. Instead, they'll be free to wander around the surface safely ensconced in spacewalk equipment supplied by Axiom Space and Collins Aerospace. Those researchers won't be on foot either. Just as the Apollo astronauts famously bounced around on NASA's first-gen lunar rovers, the Artemis missions will use new lunar terrain vehicles. The unpressurized buggies are currently still in development, but NASA expects to have a finalized proposal ready by next year and have the LTVs ready for service by 2028. When not in use, the LTVs will be parked at NASA's Artemis Base Camp at the lunar South Pole, alongside a pressurized version designed for longer duration expeditions. The surface habitat itself will be able to support up to 4 residents at a time and provide communications, equipment storage, power, and most importantly, robust radiation shielding. A specific site hasn't yet been officially selected, though mission planners are looking for areas near the region's permanently shadowed craters, where water ice is expected to be most easily accessible, aside from the negative 280-degree temperatures and perpetual darkness. The base won't start out as much, but with each subsequent trip, the habitat is expected to grow more capable, comfortable, and homey for the quartet of researchers who will be residing there up to a month at a time. And from there, it's a short interplanetary hop to Mars.